This is video lesson 3, standard deviation. And what deviation means is the difference between a data value and the average for the same set of data. Standard deviation is a measure of the scatter of data values in relation to the average. A low standard deviation means the data values are close to the average. A high standard deviation means the values are far away from the average. So ideally, like let's say an example, I'm marking your guys' math scores from a test. I want a low standard deviation. I want to figure out what the average was for those test marks. And I'm hoping that everybody's marks are really close together, that close to the average. And that means that I would have a low standard deviation. To solve for standard deviation, we have the following equation. And to break up that equation, standard deviation is represented by a lowercase sigma. To solve for standard deviation, I take each data point, which is represented by x, I subtract it from x bar, which is the fancy way of saying the average or mean. I square that. I add up all the sums, divide it by the number of data points there are, and take the square root. So for example, we're going to find the standard deviation for the following sample. There are 8 x values, and I need to first solve for the average. I did the work over in the corner, and when I add up all 8 points, divide by the number that is there, so divide by 8, I get the average is 21. We could solve for standard deviation by breaking it up in this format, but that gets really, really messy. So we're going to organize our data into a nice chart. So we're taking each x value, and first we have to subtract it from the average. So what is 6 subtract 21? So we get negative 15. 9 subtract 21, negative 12. 12 subtract 21 is negative 9. And I'm going to continue filling in the chart, and I would like you to do the same. Now that we've taken each data set and subtracted from the average, I need to square my answer. So negative 15 times negative 15 is 225. Negative 12 times negative 12 is 144. And I'm going to continue squaring each data set subtracted by the mean. Perfect. Now I need to add up all of those values. So when I add up 225, 144, 81, 36, 4, 36, 289, and 441, I get 1,256. So right now, if I write out our formula for standard deviation, I'll show you what part we're at. All right, so we have taken each point, subtracted from the average. I then squared it. I added up all of my values, and now I'll divide by the number that are there. So we have 8 points. I need to divide 1,256 by 8, which gives me 157. Lastly, I need to square root. So I'm going to square root 157, and I get 12.53. My standard deviation is 12.53. So you can represent standard deviation with that lowercase sigma, or just put SD, standard deviation. Okay. We can also find the average for data when it's grouped into intervals. So I'm going to use the example that we had from last lesson, where we were solving for a number of data points. So this was the example where there was 30 test results from a math exam. We broke them up into intervals. So we broke them up into the intervals 40 to 49, 50 to 59, 60 to 69, and so forth. So we made sure those intervals were even. And then we had to figure out, well, how many times did a exam fall in the interval 40 to 49? And that happens twice. So that was the frequency. There were 4 marks that fell in the interval of 50 to 59, 7 marks that were between 60 and 69, and we keep going until we get down to all 30 of our exams. So all 30 marks are accounted for. If we're going to solve for the standard deviation of values that are broken up into intervals, we need just one single x value. And that x value is going to be represented by the midpoint. So the number that's in between 40 and 49 is 44. The midpoint between 50 and 59 is 54. So I'm going to keep going and write the midpoint between each interval. Good. Next step, we need to figure out, well, how many times did I have exams within that interval? So my midpoint is 44. I need to now take that midpoint, multiply it by the frequency. So I'm going to go ahead and fill in that data. I'm actually going to jump to the next page where I have my full chart. So 44 times 2 is 88. 54 times 4, 216. And keep filling in your chart. All right, next we're going to take each midpoint times that frequency, and we're going to subtract it from our average. Our average will add up all my points. So I'm going to add up all these guys, and I get 2,127, which I have to divide by the number of exams I had. So divide by 30. My average is 70.9. So I'm going to go ahead and I'm going to take each, change the color here. I'm going to take each point here and subtract it from 70.9. So what is 88? Subtract 70.9, we get 17.1. 216 subtract 70.9, 145.1. I'm going to continue filling in our chart. You do the same. Cool. All right, next step in my chart, I need to now take each of these values and I need to square them. So 17.1 times 17.1, 292.41. Okay. Next step in my standard deviation equation, I need to take the sum of all these points. So I'm going to add them all up in my calculator, and I get 689,458.26. I can't forget to divide by 30, which gives me 2,298.94. Lastly, square root your answer, and you get 151 decimal. We need to round up, so we get decimal 6. So when data is concentrated close to the mean, the standard deviation is low. When data is spread far from the mean, the standard deviation is high. As a result, standard deviation is a useful statistic to compare the dispersion of two or more sets of data. Standard deviation is often used as a measure of consistency. When data is closely clustered around the average or the mean, the process that was used to generate the data can be interpreted as being more consistent than a process that generated data scattered far from the average. So here are your practice questions I want you to do. Practice 3, questions 1, 2, and 4.